We're Team 6, and from Lab 1 we made problem 31, and from Lab 2, number 30.
So I'm going to talk about permutations and combinations. And first off, I just want to say what a permutation is. A permutation is similar to that of a combination, but the order of factors is relevant. This means that various different possible outcomes can be achieved by using the exact same factors, but arranging them in a different order. So by this, we can start to understand what the different types of permutations are. So the first one is permutation with repetition. We have this formula n to the r. So n is equal to that of the options or outcomes that you have, and r means how many of these options are you going to pick. So for example, let's say you have a locker combination. You have 10 possible digits, 0 through 9, and you're only allowed to pick 3. So you do 10 times 10 times 10, or 10 to the 3, and you get your answer, which is 8,000 possible combinations. For permutations without repetition, you have this thing called factorial. So with numbers are factorial, you have to multiply all the integers below all the way to 1. So you plug your numbers into your formula. Your n is 4, your r is 2, so you have r 4 p2. You plug it in and you get 12. Next up we have combinations. Same logic applies. The thing is that with combinations, the order of how you do things is relevant. So for example, we have this table, and for permutations, we have 12 possible answers when we have 4p to the 2. But with combinations, we only have 6 answers because combinations consider AB and BA the same thing. However, for a permutation, AB and BA are completely different answers. So now that I have explained what combinations and permutations are, I want to let my classmate Jose Andoni do some examples so that the topic at hand can be fully understood.
I'm going to make problem number 31 from the first lab. Here we have 3 problems in the same problem. It basically says that there's 6 people and 6 places, and you need to know how many ways there are so the people could be seated. So in the first one, you just put in the calculator 6, P6, and this is the way you put the 6. Then P is shift, and here P, and then again 6. And it gives you 720. Then in B, it says that Fernanda wants to sit in the left window, which you need to discard one person and one seat. So it's basically the same as the last one, just it's 5 P5, and that gives you 120. And in the last one, which is C, it says that Fernanda doesn't care if she sits on the left side or the right, in the left window or the right window. So you need to make the same thing as that you did with the B, except twice, because the first option is the left window, so you need to make the probability for the left, and the second option is the right window, so you need to make the probability for the right. So you type in the calculator same as B, but times 2. So I'm gonna put the parentheses here and the 2 over there. Okay, wait. And there you go, 240. And that's basically how you do this problem, or this kind of problems. Thank you.
Hello, today I will be explaining what are continuous random variables. But first of all, you need to understand there are 2 types of random variables. First, there is the discrete, and then there is the continuous variables. And a discrete variable is a variable where the values are obtained by counting, and a continuous variable is a variable whose value is obtained by measuring. Okay, so now what is a random variable? Well, a random variable is a variable whose value is a numerical outcome of a random phenomenon. And well, the data of a continuous, or x, when you're putting in a problem, it can take infinite many solutions, like way many solutions and values for the x. And well, If you see it in a table, the probability distribution of x in an interval table is described by that it's like density curve, and the probability of any event in the area under the density curve and above the values of x that make up the event. And well, continuous random variables can also be used in real life situations. For example, you can use it to find the exact age of someone, like if you want to know the seconds, minutes, weeks, months, and years he's been living. And you can also use it to know the exact temperature, weather of something you want to know. And you can also use it to body mass, height, blood pressure, cholesterol levels, or on someone's. And so basically on every medical thing you want to know of the body of someone. And well, there's many other things that continuous random variables are used for. So well, in conclusion, continuous random variables are an effective way and fun way to obtain the exact value of something you're trying to find.
So now that my classmate has explained to you what a continuous random variable means, I would like to explain it to you better in a problem, in an example. So the problem is that the density function of a continuous variable is given by 1 over 6 times square root of x in the interval 1 x 16. So first we need to find the expected value, which is the mean, and this is the formula to find it. So first we multiply this x. First we multiply this x times the function, which is this one, and we get this, which if we simplify it, it turns into this. Okay? So then we integrate this function, and this is what we get: x over 3/2 over 9. 3x. So now we use this part of the formula, which we will do first 16 to the 3/2 over 9 minus 1 to the 3/2 over 9. This is the two limits. So this will give us, if you plug it in the calculator, this will give us 7. So this is the mean. Okay? So now to find the variance, which is the expected value, but of the x squared here instead of the x, the normal x, minus the mean squared, which is this one. So in order to find this one, we would have to do like almost the same process, but it would be x squared of 6 times square root of x, which would then be x to the 3/2 over 6. And if we integrate it, we will have x to the 5/2 over 15. So that's what we have. Then we need to do the same as this. We have 16, square root of 16 to the 5th over 15 minus square root of 1 to the 5th over 15. Okay, so this we plug it in the calculator right here. We have to subtract this one squared, so it's 68.2 minus 49, and we get 19.2. So now, to find the probability of 9 and 16, what we need to do is find the integral, but only of this function without multiplying to anything, and then finding it with these two numbers. So what we get is this function. We need to integrate it, so what we get is x to the 1/2 over, you get 1/6 over 1/2. So this is like this. So that is our, we plug it in the calculator with, so this gives us 0.33, which is 33%. And we do the same for the last one, but with 1 and 9. So we plug in the calculator 6, which is equal to 66%. So that is all you need to know. Thank you.